Hello once again. Welcome back to OpenSec Math, my beautiful people. I'm Jazzy, and today we're going to continue diving deeper into the topic we explored in our last video, vectors, by looking at a specific type of vector, parallel vector. Parallel vectors should remind you of parallel lines. Two or more lines are said to be parallel if, no matter how long you continue drawing them in a straight line, they will never meet. But I'm sure you knew that. Parallel vectors are similar. They never cross paths. And they do this by having the same or exact opposite direction. Their magnitudes can be equal or unequal. Remember that. It doesn't matter as long as their directions are the same or the exact opposite to each other. Then they are parallel. That means that these two vectors are not parallel because they're going in a completely different direction. Now, in our last video, we touched on scalar multiplication of vectors. That is, multiplying vectors by whole numbers like this. Well, one way to describe this equation is to say that the first vector with the values 12 and 16 is a scalar multiplication of the second vector with the values 3 and 4. In fact, the first vector in this instance is exactly 4 times the scalar multiple of the second vector. That is because these two vectors are parallel to each other. Two vectors are said to be parallel if one is a scalar multiple of the other. For example, if vector A and B are parallel, both would be scalar multiples of each other, where the scalar value is represented by the letter K. If you're not convinced of our explanation of parallel vectors, let's look at an example using vector arrows. Now let's say we have two vector arrows, AB and AC, which when combined forms a third vector, BC, like so. For the purpose of this example, let's say that the points P and Q are the exact midpoints of vector AB and AC. Finally, remember, sometimes we label vectors using small letters. Well, let us label the vectors formed between point A and the two midpoints A and B like this. Now, from looking at it here, we can clearly see that the vectors BC and PQ are parallel to each other. But how do we show that mathematically? Well, let's break it down using the information we have in our diagram. First, let us write a formula that describes the vector PQ. Using what we learned in our last video, PQ is equal to PA plus AQ. But look at the direction of the vectors. The vector is actually running in the direction A to P, which means that PA is actually the negative of AP, or negative little a. AQ is labeled B, which means that PQ is equal to negative A plus B, which can be rearranged to B minus A. That settles PQ. Let us use similar information to make sense of the vector BC. Again, using what we learned in our previous video on vectors, BC is equal to BA plus AC. Because the vector is actually running from A to B, BA is actually the negative of AB. Now, unfortunately, we were only given small letters for the distance between A and P and A and Q. Because P and Q are the midpoints between BA and AC in the diagram, however, it means that BA can be rewritten as negative 2A and AC can be rewritten as 2B. That means that BC is equal to negative 2A plus 2B. Rearrange, this becomes 2B minus 2A. And using what we learned in our video on factorization, yes, because our two coefficients are similar, we can just multiply the coefficient by these unknowns, which would give us 2 open brackets B minus A. Now, let's compare the formulas for our original vectors. PQ is equal to B minus A, and BC is equal to 2 multiplied by B minus A. Therefore, BC is equal to 2PQ. Now, what did we say about parallel vectors? We can tell that they are parallel when one vector is a scalar multiple of the other. Well, as you can see here, BC is twice the scalar multiple of PQ, which means the vectors are parallel. And that's it for today. Don't forget to rewatch this video if you need to brush up on anything. And remember, if you feel yourself beginning to get cold feet or cold sweat when facing a question on vectors, don't panic. It's just maths. But reduce your chances of feeling lost in the exam room by rewatching this and all of our other videos on OpenSec Math. And that's it for today. This video was sponsored by BP and produced by the 2 Cents Movement with the help of these beautiful people. Be sure to like, share, and subscribe to our channel for more videos. Vámonos!